Welcome to the glycogen experiment for BS1002 cellular processes. This short video should help you prepare for the practical and answer the quiz that you will have to do before coming to the practical. The aim of this experiment is to test the effect of temperature on enzyme activity. As we have discussed, there are two main factors that we have to consider when looking at temperature and enzyme activity. On one hand, an increase in temperature increases the kinetic activity and thus increases the chance of the substrate and enzyme to come together. On the other hand, the delicate structure of a protein can be affected by the temperature and therefore can lead to denaturation of a protein. There is thus going to be an optimal temperature for each enzyme. The reaction that we're going to be studying is the breakdown of glycogen. Glycogen is a chain of glucose molecules. The enzyme amylase can cut the alpha-1,4 linkage between the glucose molecules. As it can be seen here, amylase, like any other enzyme, has a very complex structure, and its three-dimensional shape is essential for its function. The measurement of the production of free glucose will be done by a reaction with DNSA. DNSA, when it reacts to glucose, forms a product of a much darker color. Incidentally, this bit of a reaction is non-enzymatic reaction and therefore requires temperature, as you will see later. In order to prepare the experiment, you will have to aliquot 500 microliter of DNSA into 7 different tubes using the dispenser provided. You will also have to prepare your working solution for the reaction solution. This is where you will have to apply your calculation for dilutions. You'll be given a stock of glycogen and of buffer, and you will have to prepare a final solution at the concentrations indicated. Either using a dilution factor or using the formula C1V1 equals C2V2, you can calculate the amount of each of the two solutions that you need to make up a total volume of 5 ml. Make sure you make these calculations before coming to the lab so that you can be ready to go when you are in the lab. Once you've prepared your assay mixture and before adding the enzyme, you should take one aliquot of 500 microliters and add it to the first tube containing DNSA. You should then incubate your tube with the assay mixture without the enzyme in a water bath at the temperature that you have selected. Each group will be using a different temperature. After about 5 minutes, when the tube will have equilibrated to the temperature of a water bath, you can take one 500 microliter aliquot and add it to the second tube. This will be your time zero point for the reaction. You can now add amylase, the enzyme, 500 microliters into your reaction mixture. This will start a reaction, and therefore you need to start your clock. After 2 minutes, you will take 500 microliter from your enzyme mix and add it to the third tube. Adding the enzyme mix to the DNSA stops the reaction. Therefore, this will be your time 2-minute point. You're going to repeat this every 2 minutes so that you will have a recording of the reaction every 2 minutes. At 10 minutes, you'll be adding the last sample to tube number 7. You will now need to place your tubes in a rack in a boiling water bath. As I mentioned before, this is to get the reaction between the glucose and the DNSA. You should find that at least for some of the tubes, the solution will have turned a darker color. This is actually too dark to measure, and therefore you need to dilute it down by adding water as described in the protocol. You're now ready to measure the absorbance of your samples. Using a spectrophotometer at the wavelengths indicated, measure each sample and make a recording of that. Each one of you will have done the assay at a different temperature. We now need to collect the values that each group has done to get a class results in order to estimate the effective temperature on the enzyme. Each one of you will need to report the measurement that you did at 2 minutes, but you will be reporting it as an activity per minute. Therefore, you will need to divide your value by 2. Before doing that, you must also subtract the value of your background, which is the value that you got at tube number 1. Using the class results, you will be able to estimate the optimal temperature for the enzyme. Remember to use the plot intelligently. First put the points and then use a best fit to join the points. The value that you reported so far are absorbance values. They don't really tell us how much glucose is actually being produced. In order to do that, you need to use a standard curve. In the protocol, you are given values to build the standard curves as one shown here. From that standard curve, you'll be able to calculate the actual glucose concentration that correspond to the absorbance values. It is important that you make all this calculation and keep a good record of them in your lab book, because in your final MCQs and other MCQs, you'll be asked questions about this. When you come into the lab to do the experiment, remember that there are certain things that you need to be particularly careful about. The DNSA is toxic, and you'll be using water boiling bath, which can always be dangerous, especially when there are a lot of people in the lab. You now need to proceed to do the quiz, which you will need to complete before you can come to the lab. I look forward to see you there.